Today we're going to take a look at how we locate positions on Earth's surface. As you know, in the Middle Ages, a coordinate system was developed. This system is based on lines of latitude and longitude. What you may not know is that these coordinates and lines are actually based on observations of the stars. We'll get into that more in class. So for now, let's focus on the actual lines of latitude and longitude. Lines of latitude run across the Earth and tell us how many degrees north or south of the equator a location is. I like to think of latitude like a ladder. Latitude, ladder. When I'm painting my house, or if I need to get onto my roof, I use a ladder to reach locations that are higher up. And then I can climb back down to get to lower locations. We can think of latitude just like a ladder. If we start at the equator, which is 0 degrees, and we follow the steps of latitude, just like the steps of a ladder, they will take us further north to higher latitudes. And if we go all the way to the top of the Earth, all the way north, we reach the North Pole, which is 90 degrees north. We can also take the lines of latitude south, below the equator, and you'll notice that the latitudes also are increasing as you go south towards the South Pole, which is 90 degrees south. Take a look at those latitude lines on that map. Do they touch each other or cross each other? Right, they don't, because they're all parallel. For this reason, lines of latitude are called parallels. In Earth science, we often look at the Earth in a slightly different point of view, more like the one you're seeing there. You'll notice that from this perspective, the North Pole is in the middle of the image. Where would you have to be in order to be seeing the Earth looking like this? Right, you'd have to be flying in space above the North Pole, looking down. Now let's take a look at what lines of latitude look like from this perspective. Along the outer edge of the Earth, there would be one line of latitude, shown in red. That's actually the equator. So we're seeing right now everything north of the equator, the whole northern hemisphere. As we travel upward from the equator, what we'll find is our lines of latitude become smaller and smaller circles and remain parallel to each other. You already know that latitudes range from 0 degrees at the equator to 90 degrees at the North Pole and the South Pole. But what does that mean? Well, let's use Rybrook as our example. Rybrook is located at approximately 41 degrees north, somewhere right over there on the Earth's surface. 41 degrees north means that if you started in Rybrook and you dug straight down to the Earth's core, and then you dug straight up at the equator, you would find that inside of the Earth, that angle is 41 degrees. Now we know from math that if you have two lines that form an angle, anywhere between them is the same angle. So at the surface where Rybrook is, we are 41 degrees north of the equator because of that angle that's formed down over here. Same thing is true at the North Pole. If you start at the North Pole and you dig straight down to the Earth's core and you come up at the equator, you'll see it forms a right angle, a 90-degree angle. And that's why the North Pole has a latitude of 90 degrees north. Now let's take a look at longitude. Lines of longitude run from the North Pole to the South Pole, and they measure the angular distance east or west of the prime meridian. Unlike lines of latitude, you'll notice that lines of longitude do touch each other. In fact, they all meet at the North Pole and the South Pole. Lines of longitude are also called meridians, with the 0-degree line of longitude called the prime meridian. Let's take a look at what these look like from a polar view. So here we are again, we're flying over the Earth's North Pole. We're looking down at the Earth. And as we just mentioned, lines of longitude all connect at the North and South Pole. So from this point of view, this is what they would look like. Sort of looks like the spokes on a bicycle wheel. Here's another diagram of the Earth showing lines of latitude and longitude. Okay? The prime meridian is located over here at 0 degrees longitude. You'll notice that the prime meridian runs right through Greenwich, England. And that's an important fact that we're going to talk about many times during the year. Now, I want you to notice, if you start in Greenwich and you follow the prime meridian all the way up to the North Pole, and you continue on the other side of the Earth, you reach the 180-degree line of longitude. That line is special. It's called the International Date Line. And together, the International Date Line and the prime meridian separate the Earth into the Eastern Hemisphere and the Western Hemisphere. So if we start at the prime meridian and we travel eastward, our longitudes would be getting higher. The numbers go up all the way until we reach the International Date Line, 180 degrees. This whole side of the Earth is the Eastern Hemisphere. If we start at the prime meridian and we travel westward, our longitudes also would be increasing higher and higher and higher until we reach 180 degrees, again, the International Date Line. So this side where North America is, this is all the Western Hemisphere. So again, increasing longitude means we're moving away from the prime meridian, either towards the east or towards the west. So to recap, lines of latitude are called parallels, just like the steps of a ladder. They run across the Earth, and they measure the angular distance north or south of the equator. Longitude lines are called meridians. They run from the North Pole to the South Pole, and they measure the angular distance to the east or to the west of the prime meridian. Let's take a look at some maps and let's apply these concepts. So this map is a map that you're familiar with. You've seen these a number of times, and you know that the equator would run right across the middle of the Earth, and that would separate the northern hemisphere from the southern hemisphere. The prime meridian runs from the North Pole to the South Pole. Again, it goes right through Greenwich, England, right over here. And that separates the Eastern Hemisphere from the Western Hemisphere. Now, open your reference table to the map on page 4. This is a map showing surface ocean currents. We're going to learn about the currents later in the year, but for now, let's just focus on the latitude and longitude lines. So first question, can you find the equator? Well, there's nothing surprising about that. The equator runs across the middle of the map and is 0 degrees of latitude. There are a few other important lines of latitude that are also on this map. If we travel northwards a little bit, we come to this dotted line. That dotted line, located at 23.5 degrees north, that's the Tropic of Cancer. And if we go 23.5 degrees south of the equator, we reach the Tropic of Capricorn. If we continue south to 66.5 degrees south, we reach this line over here, which is the beginning of the Antarctic Circle. And if we travel north 66.5 degrees, we reach the Arctic Circle. So those are our important latitude lines. Now let's look at longitude. Can you find the prime meridian? Well, remember, it's 0 degrees longitude, and it runs right through Greenwich, England. So if we look at all of our numbers on the top, here is 0. So that line right there is the prime meridian. Go ahead and take a ruler and draw that line onto your reference table and label that as the prime meridian. Now let's figure out where the eastern and western hemispheres are. You'll notice that none of the longitude markings are labeled east or west. So you're going to have to be able to figure out which are which. So as we said earlier, The prime meridian and the international dateline at 180 degrees, those define where the eastern hemisphere is and where the western hemisphere is. Go ahead again, use a ruler and draw that international dateline onto your reference table and label that. It'll make life much easier as we go through the year. Now let's figure out where the eastern hemisphere is and where the western hemisphere is. Okay? We'll start with the prime meridian. We know that if we go west from the prime meridian, it brings us to the western hemisphere. As you travel west, you'll notice that the numbers are getting bigger. So starting with 0, 20 degrees, 40 degrees. If you travel west and the numbers get larger, that tells us we're in the western hemisphere. So put a big W on your reference table in between the prime meridian and the international dateline. Everything between 0 degrees and 180 degrees in this area of the map, this is the western hemisphere, which means that everything else on the map is the eastern hemisphere. So let's go back to the prime meridian. Let's travel eastward this time. Now the map ends at 20 degrees, but it continues at that point over here on the left side. So this 20 degrees is the same. As we move to the east, we'll notice that our numbers are getting bigger again. So 20 degrees, 40 degrees, 60 degrees, and so on, all the way up to the international dateline. So this part of the map represents the eastern hemisphere, which actually starts over here on the right side. So if you want to put an E there for east, you can certainly do that. So let's put this all together and let's determine the latitude and longitude of an area on this map. Let's take a look at the D in the word India. We want to know what the latitude and longitude is of that lowercase d. When we write latitude and longitude, we always record the latitude first. So let's start with that. So this D is located approximately at that 20 degree mark. So the latitude of India, or of that D, is 20 degrees north. So we write it like this, 20 degrees, capital N for north. Then we're going to put a comma. And now we're going to write the longitude. The longitude, again, I'm going to estimate here. It's roughly, and again, we'd want to use a ruler or a straight edge when we use this map, but it's roughly 80 degrees, and we've already noted that this is the eastern hemisphere. So the longitude is 80 degrees, put our little degree symbol, capital E for eastern hemisphere. Now take a look at the map on page 5 in your reference table. This is a map showing the Earth's tectonic plates. Again, let's ignore all the information in the map and let's just focus on the latitude numbers and the longitude numbers. Again, nothing is labeled. There's nothing north, south, east, or west. You're going to have to be able to determine that by yourself. Let's figure out the coordinates of the capital A over here in the African plate. So again, we always start with latitude. So the A, the capital A, is located, again, near the 20 degree mark. And this is 20 degrees north of the equator. So the latitude is 20 degrees north. And if we focus on the longitude, it is roughly, again, a straight edge comes in really handy. It's located right over there. So we're going to estimate and say that that's about 18 degrees. So we put our comma and we write 18 degrees. And again, here's the prime meridian. And we are to the west of that. So 18 degrees west.